What is up, guys? Welcome to another episode of Casual Code Talk. And today I'm going to be trying a medium problem that I haven't seen. Okay, correction. I've done this like many months ago, but I do not remember it at all. And I just saw it again, and the question looks cool. Don't have any ideas of how to do it yet. So I thought I'd record myself going through the process of doing this. So again, I did this apparently 7 months ago, Christmas break, I guess. And I'm back at it again and want to see if I could do it this time, if I remembered anything. So the problem seems interesting. It's called remove the nth node from the end of the list. And so it's a straightforward problem. You get a linked list, and you have to remove the nth node from the end of the list and return its head. So n is 2, so you have to remove the second from the end node and then return the 1. Okay, so I'm just thinking, if we're going through, let's draw something out. Let's get a purple. Yeah, dark purple. Alright, so if we're going through a linked list like this, if we're going through it, we will know we're at the end only when we get to this null. Oh wait, I totally know how to do this. This isn't hard. Okay, so once I get to this null, I guess I could do two things. One, I could keep track and count how many nodes there were until I needed to get to null. So if it was 1, 2, 3, 4, 5, including the time that I got to null, that means there's 5 nodes. And if you need the second from the last one, then you know you just go 3, 1, 2, 3, and this is the element you remove. How you remove an element is you just have to remember the previous one, and you move the previous node's pointer here, and then you delete this. Then after that's done, you can just return the head. So what complexity is that? Well, that's just O of n, but it's O of 2n, right? Because you have to go through it once to the end, and then you have to go through it a second time. So that is O of, we'll just say, I will include the constants for now. But then the other more clever way, which is also the same complexity, is if you, let's say you need the second from the end. Maybe you have a pointer, 2 pointers that start off here, and then you if you want the second from last, you let one of them go on that many spaces. So if you want the second from the last, you let, let's see, this is green too. There. You let this, like, we'll call it the fast pointer, go up here, and then you both move together until you get to the end. So the fast pointer now moves 1, slow pointer moves 1, fast pointer moves again, slow pointer moves again. So it's basically the fast just got a head start, and then when the fast gets to null, you're like, okay, let's finish off the slow one, and this is the place where you have to stop and delete. Again, remember the previous one so that you could do the deletion fast. What's the complexity of that? I guess that's also O of 2n, because it's only going through it once, but it's doing 2 operations every iteration. So I guess that's it for this one. Yeah. Could you do this in one pass? Yes, this is the one pass version. I guess I'll do it that way. They are both the same complexity though. Okay, let's do it. So we got list, node, fast. We'll start them both off on head. And then we got list, node, slow, which also gets head. And then let's do a quick little for loop. I is less than n and I plus plus. So all we're going to be doing here is saying fast gets fast.next. So we're going to make the fast actually get that head start so that it could start at 3, for example, if we are going 2 from the end. We need the fast to have that 2 head start, or the n head start if we're looking for the n node from the end. Okay, great. Next, so when we work with linked lists, we're always going to be using, like when we want to iterate through them, we always want to have a while loop and while they don't equal null. The quick way to do that is you could just do fast. Well, I guess fast is already ahead of slow, so we don't need to check if slow is null. And if fast isn't null, then it evaluates to true. That's why it goes through here. And when fast is null, it evaluates to false and breaks out. This is just a quick notation. It's equivalent to saying this. But I like the quick notation, the cute syntax. Okay, so now we're going to say should I check it now if fast equals null? Oh yeah, we also have to have the previous. I'll think about that in a second, but now fast is going to get fast next, and slow is going to get slow next. Oh, before we do that, previous gets slow, and then we could check if fast equals null. So how we make, if we want to say fast equals null, it's like that. Then so if fast is null, delete what the slow pointer is pointing to. So to do that, what we do is simply previous gets previous gets what slow next is, and then we is it delete slow? Is that how you do it? I'm not sure about that syntax. How to delete a pointer, or like what it's pointing to. Deleting a pointer. Is it just delete? Oh, I think it's delete. Yeah. There, now it's like nice and blue. Okay, so then delete, and then we can return the head. We never moved it. We really never moved it. We shouldn't be able to get here, but that's that. let's go through the logic again because I think there's a few edge cases that we've missed. So fast, they both start at head, and then fast goes to this area. Yeah, it's second from the end. I'm just trying to think if it's possible for it to go past it. I don't think so. No, because if it's like fifth from the end and there's not even 5 nodes, this is not a proper end. It wouldn't be valid. So this is going to work. What if n was 0th from the... No, it has to be 1, I think. So it's at least 1 from the end, so it's like already at the tip here. Let's imagine. Or, wait. No. If you want the second... Oh, okay. It's like, imagine you want the 5th from the end, so then fast has to go 1, 2, 3, 4, 5, which would be null. And you want to delete this one, which is valid. You want the 2, 3, 4, 5. Yeah, so if n does equal null, then you could just return head next. Okay, I feel like... Is that case covered? No, it's not. So, if not fast, sorry, then we can delete... Okay, we need to do this. So list node temp gets head, head gets head next, and then we delete temp and then return head. So that is the case if you want the nth one from the end when n is the entire list. Okay, so now that fast is at least here, then we could go into this cycle, and we know we're going to get through this at least once, so meaning we can get to here at least once. Oh, true. Like, we already have fast and slow covering it. We don't need this. Slow. Honestly... Yeah, okay, that's fine. Okay, so then we're guaranteed to go through here once, and then, for example, let's say if the fast pointer is here because you wanted the 4th from the end, and that would be 1, 2, 3, 4, and then slow's here. Then the next iteration, slow will be at 2, and fast will already be at null. So that's here. So fast gets the null, previous gets the 1, because that's what slow is now. Slow moves on to the 2, and then here's the check. And as long as we could get to this check at least once, we're good. That's why we needed this check if fast was already null pointer. Okay. Cool. I don't think that it should ever get here, so I'm going to just return null pointer. That seems like the appropriate thing to do. And yeah, if not... Okay, what if... Yeah. I was going to say what if head is null pointer. So that means that n has to be like 0 or something. fast and slow both get null pointer. This isn't going anywhere because n has to be 0. We're assuming n is valid, so the only valid end if head is null pointer is 0. And so fast is going to go through here because head was null pointer. And then, yeah, that's kind of a problem. Yeah, that actually is a problem because you can't do head next. All right, if head is null pointer, return head or null pointer. Let's run it. Yeah, my bad. List node pointer. And oh god, this is so unhelpful. So keep use after free. Use after free. Okay. Where? So wait, what's the test case that was put in here? So I don't think it's gonna go through here. So then here, if you want the second from the end, you delete. So you said keep use after free on address. There is located 0 bytes inside previously. Okay, yeah, like that helps. It doesn't like the delete. You know what? Delete is actually not a necessary thing. So what if I get rid of this for now? Previous gets slow next. That makes sense. Yeah, I just want to see if we could get past. Maybe I'm forgetting something about delete. What is... Okay, can we see out the previous value? Is that how you do it? Yeah. Before it gets... So really the 3 we want to be pointing... Oh, okay, I already see it. It's previous next needs to point to that. That still doesn't explain why this was causing a problem. Right, because, yeah. Okay. I mean, I think this is still going to cause a problem, honestly, because, I mean, I don't know why. Oh, wait, why is that not causing a problem anymore? Okay, not sure, but whatever. Submit. Sick. We got it right. Pretty much first time. So, yeah, we did a good job at, like, after going through it, thinking of the edge cases, running through, for example, when n equaled the size of the entire list. We got that case, and we also got this case here. I think those are great things to talk about. This is also passes through it once, and it's O of n complexity. Passing through it twice would also be O of n complexity. I mean, I say this is O of 2 of n also because we do this and this. Yeah, technically there's a few more operations, but like going through something twice and doing half the operations as going through something once is the same thing. It's probably more like elegant this way though. So whatever. Alright, I hope you enjoyed this video. I made some mistakes along the way, which is always the best way to learn. I love when I watch people and like I see them making mistakes because it points out things that are tricky. So I hope you guys learned something. As usual, if you have any videos you want me to do, just drop it in the comments or message me somehow, and I will be sure to do those. All right, thanks. Bye.